Hello again. This is a tutorial about symbols, schematic symbols, components, and how they interact. And this is the simplest form that I found of a book, how to try to explain it the simplest way. Now, first of all, let's go for the pictorial. These are the actual components, and this is called the flashlight. We've all used flashlights. There's one thing missing here. We'll get to that in a second. First of all, you need a battery. As you can see, positive and you can see negative. With wires or conductors, it goes to a bulb. So one conductor from the positive to one side of the bulb, other side of the bulb going to the negative. What's missing here? We've all used flashlights. A switch is missing here. You have no switch. Now, you also don't have the value of the battery. It could be 9 volts, could be 1.5 volts. Is it A, B, C, or whatever? Doesn't say it. But this is just a pictorial so you understand what we're referring to. The actual schematic symbols of it, these are conductors, this is a lamp, and this is a battery. Now let's put them in a schematic. This is the same as this pictorial. There's a battery, a positive. You see, the positive tells you it's a positive, but the negative does not give you the negative sign. You're supposed to figure it out. So the bulb is here. One side, one conductor goes from the positive of the battery to the bulb. Other side of the bulb comes back, and there's a connection to the negative. Again, doesn't tell us the value in this schematic of the battery. It doesn't label B1. It doesn't label the bulb. L1 or B1 or C1, doesn't any information. And of course there's no switch, but a connection from here to here, a connection from here to here. Now let's take it a little further. Again, a flashlight. Now look at the two different circuits or schematics, but you'll know in reality actually that these are two of the same things. These are the same things. This is a bulb, this is a positive, one conductor from the positive to the bulb, other side from the negative to the bulb. Now, the same thing over here. One side from the positive to the bulb, the other side of the bulb to the battery. Again, doesn't tell us the value of the battery, the voltage. Now, if you look at these, and I was asked a very good question actually, this is almost the same distance as this one. I was asked the question, if positive goes to here, does this mean we use a shorter wire from the positive to here, and we use a longer wire from the negative to the bulb? That's a very good question actually. Not really. Because all this is telling you is there's a conductor we connect from here to here, and another conductor from here to here. Again, we can make this 1 foot, we can make this 2 foot, we can make this 1 inch, we can make this 3 inches. But when it comes to electronics, we want to keep wires, conductors, as short as possible. Especially in, sometimes you have applications where you have radios and interference, magnetic fields. We want to keep the wiring as short as possible. We don't want to make a mess. So that was a good question, because this one over here looks like it's equal, and this one looks like it's equal, but this one looks like it's smaller distance, and this is longer distance. That doesn't matter as long as you have a connection from here to here, and then you have a connection from here to here. Very good question actually. Next, batteries, again, conductors. What did we say was missing? A switch that we didn't have in the other ones, right? Look at this one. See, this is positive. This is also positive, but tells you it's negative. That's not true. This is the positive one. The small one is the negative one. Let's go to another one. Now we're cooking. Now, how many cells do we have? These are called cells, battery cells. 1 cell, 2 cell. What do we have here? Same bulb. Now we threw in a switch. Single pole, single throw. So, do we know the values of these batteries? No. Maybe this is 1.5, maybe this is 3 volts, maybe 6 volts each cell. We don't know. It doesn't give us this information. All we know is we're making connections. We make a connection from the positive to the bulb. The other side of the bulb goes to one side of a switch. Other side of the switch goes to another battery cell. Then the positive of this battery cell goes to the negative of the first battery cell. So these are in series. Remember, flashlights, you have batteries in series. They add together. So if we would have two in a flashlight, 1.5 and 1.5, together they would give us 3 volts. If this would be 3 volts, this would be 3 volts, we would have 6 volts. They are in series. See, positive to negative means they are in series. What's missing? A fuse. Now let's get to some other things over here. An antenna. A diode, we talked about it. A coil is any wire that's wound up. We could make turns from a wire. You could make it into a coil. And a motor. This is always in automotive. Now, those symbols now. This is a motor. This is the coil that we refer to. This is a symbol for the antenna. Now, is this a receiving antenna? Is it a transmitter antenna? An antenna could be transmitting and it could be receiving. Actually, excuse me. Actually, this is a receiving antenna. Receives the strength of something, it rectifies it to DC, and then you have a meter over here. Actually, this is a meter. Now, polarity is important for this one. Polarity is important for this one. What's missing here? It doesn't identify this as D1, D2. Doesn't tell us if this is M1, M2. It doesn't tell us this is L1 or L2. The abbreviations for the components are missing. And you'll understand why I am talking about that. Now, a fuse here. A plug here. We make one connection from one side of this and then the other side of this. So therefore, this is a transformer. This is an iron core, it's called. And this is a capacitor, and this is a die. So in this schematic, it tells us the components. This is just a basic diagram. That's what you will not find any diagram that it tells you this is a capacitor, this is a resistor. What's missing here? Well, the actual abbreviations for each one, the idea of each one. D1, C1, R1. What else is missing? The value. Doesn't tell us, is this 10K? This is 100K? Is this 10 microfarads? Is this 20 microfarads? What kind of diode is this? It doesn't tell us. Is this T1, T2? Doesn't tell us. F1, F2? Doesn't tell us. Is this 120? Is this 220? Doesn't tell us. But as long as we're just trying to get familiar with the symbols. Next. Again, now you understand why I brought up that point. You see over here? We're slowly building up to getting a little more proficient in reading symbols. You see what it says over here? P1, the power cord. F1, the fuse. T1, transformer. D1 is the diode. C1 is a capacitor. And R1 is the resistor. Still doesn't tell us the values on the schematic itself. And this is the output, how much you should measure. And this, with respect to polarity, this is positive, the output. This is called the output. And this is called the input. A transformer has an input, in this case AC, and this will be the output. Notice there's isolation between here and here. There is no direct connection in the transformer. This is the output, positive, and this is negative. So this changes AC to DC. Now, why I brought up the point, see over here? We were talking about, how do I know the value of R1? Guess what? all this information is given sometimes over here under the schematic. Sometimes they'll have it right here written. In other words, they'll say this is 10K. And this will tell you F1 is, okay, a half an amp, right? It'll give you the information right next to the component symbol. In this case, it gives us underneath. As long as we know the information, that's okay. So now we can plug in for each one. So P1 is a male one. You can have a female, you can have, but mostly obviously it's a male plug going in. We still don't know, is it 120? Is it 220? Probably it's 120. Now the D1 is a diode. This is called a peak inverse voltage, but that's not now for this lesson. C1, what's the value? 100 microfarads. Is it polarized? Yes, this is positive, this is negative. 100 microfarad electrolytic means it's polarized, and the working voltage for it is 50 volts. If I would not see this, I would not know how much each one is. This gives me all the information that I need. T1, 115 volts. That means this has to be 120 volts input. If the primary or the secondary, this is called the primary, this is called the secondary, the output. 115 volts is the input. 12 volts is the output. So we're getting better, hopefully, with this. Now, also over here, you have the abbreviations. What is antenna? Sometimes you have, like we just mentioned, C is for capacitors. B is usually used for batteries, like B1, B2. Capacitors, usually C1, C2, C3. Fuses are usually F1, F2. And so this is the chart that we use to reference each one. Resistors, R1, R2, R3. And this is how you go about understanding diagrams, right? Next, same thing over here. Now you're going to ask, wait a second, where are the values of these things, right? That's why you look over here. See, single pole, single throw, 3 amps. F1 see, gives you all the information of all these, and you just plug them in. Just like we had before. What are these resistors? What's missing? Again, we have the reference of R1, R2, R3. We're missing the value of each one. How are they connected? They're connected in parallel. And this would be the pictorial for it. 1 resistor, 2 resistor, 3 resistor, all connected across from each other in parallel. Okay? Now you could go back to the schematic and say, okay, now I understand much better. But still, what's missing? We know this is single pole, single throw. It doesn't say S1, S2, S3. We know this is the lamp. Doesn't say L1, L2, L3. And it doesn't say B1, B2, B3. We still don't know the value or the voltage of each one. If you picked up on that means you're getting much better with reading schematics. Sometimes you have on schematics, we're not going to go through the whole thing. We know these are resistors. We know this is a ground. Chassis ground. Chassis ground. We know this is, again, see what I was referring to? B1, B2, B3. We know this is battery cells. We know this is a capacitor. But what they give you is, in this one, they give you the test points, where you're going to measure. So they're making it very convenient for you, and they say, here, this is test point 2, this is test point 1. So test point 1 will be to this resistor that goes to Q1. Test point 2 is the one that goes to the base. This is called the base. That goes to, this one goes to R1. So it gives you some information, but what's missing again? What's the value of R1? 10K, 100K? What's the value of R2? We don't know. What's the value of B1? How much volts? We don't know. If you ask yourself those questions, you're getting better. Now we come to the nitty-gritty. Look at this. Now we know the symbols, but what's missing now? Is this R1? Is this R2? Is this R3? Well, you know why? We only have one component. So we didn't have to label it as R1 or 2 or 3 or 4. There's only one component. But we do know the value of it, 100 kiloohms. We do know the value of this one. Is this polarized or not polarized? Is it electrolytic? No, it's not. If you don't see a positive over here, that means it is not electrolytic. So 0.01 microfarad, 100 kiloohms. Now we were asking, what's the value of the battery, of the battery cells? Now it tells us 9 volts. Excuse me. Now it tells me single pole, single throw. It tells me over here. Now it tells me there are many, many types of transistors. This is called a transistor. There are many, many types. The famous one is 2N22222. Now it tells me which transistor I need to make this circuit. But if you picked up on the fact that it gave us the value, it gave us the voltage, it gave us the switch, you're getting better. What is this? A relay. When current goes here, this contact is closed. And it even tells you the normally open. That means it's normally open as the default. When current goes through it, it'll be closed. It'll make contact. See this dotted line? That means this is connected to this. How much? 6 milliamps. So if you understood this, you're getting much better. Now, going into this, we saw this. This is an antenna. Now we're getting better. Now it labels the reference. D1, D2, this is D1. This is C1. What do we have here? Whenever you see this, that means it's variable. It's not fixed. You can change the value of that component. I can make this 10 microfarads, 15 microfarads, 20 microfarads, depending what it is. Okay? Here again, what do you see over here? We see the resistors, but what's missing? The value of the resistors. Doesn't say how much R1 is. But we do know this is C1, this is R1, this is C2. But it does label B for base, E for emitter, C for collector, and it tells us it's Q1. You will not have this labeled in many circuits. This is just a training book. That's why it gives you this. You should know that this is base. You should know this is emitter. You should know this is collector. C1 over here is not polarized. R2, we don't know the value of R2, but we do know one value right here, 9 volts, and B1. It tells us it's B1. Which is the positive? This one. Which is the negative of the battery? This one. Where does the negative go to? The negative goes to R2. Where does the positive go to? C2. So if you're getting better at that, that's a good sign. What do we have over here? Same thing. Antenna, it tells us antenna. But diagrams will not tell you it's antenna. Again, this is a training book. R1, C2, Q1, these will be listed on the schematic. What's this? Means, again, you can change the value of this component, but when you see this. What's missing? We don't know the voltage. Where's the output of this? Right here. This is the output. That means if there's an output, there's an input. Where's the input? This is the input. So again, like I said, if you understood this, you're getting much better at reading schematics. And hopefully just go over it, pause it, and then see what's difficult, what's not difficult, and just go over it as much as you can. Thanks for watching.